Okay, so this is section 1-9 notes for algebra. It's on patterns, equations, and graphs. And so we're going to start out with a little bit of vocabulary review. And so for number 1, it says draw a line from each pair of numbers in column A to fit its description in column B. So 5, 6, and negative 5, 6, well, they are exactly the same except they're opposites. So they are right here. 3/4 and 4/3. Those are reciprocals. If I multiply them together, I will get 1, and that is a multiplicative inverse. Okay? Opposites of the fancy name for them is additive inverses. And then -2 and -1/2, well, those are also reciprocals. Again, if you multiply two reciprocals together, you will get +1. Okay, we're going to be looking at a different type of reasoning, perhaps than you've used before. Maybe you have used it or just don't know the name of it. Inductive reasoning is the process of reaching a conclusion, or what we might call an educated guess or a hypothesis, based on what we observe or based on an observed pattern. So it's a conjecture based on what we see. Based on what we see. Okay? And the main idea is that you're going to use inductive reasoning to look at a set of observations, and then we're going to write an equation. A general rule would mean like an equation is what we're looking for mathematically, or a function rule. In this example, this is not necessarily mathematical. Each piece of ice in the bucket's cold, therefore we reason that all ice is cold. So inductive reasoning, again, is based on specific observations, and then we make a broader statement or rule to fit most situations. Okay. All right, using the vocabulary, it says, use the table at the right for exercises 2 to 4. Complete each statement with one of the words or phrases below. So we're going to do add, inductive reasoning, multiply, pattern, or subtract. And so it says to find the value of item 5, you can look for we're going to be looking for a pattern. And then to obtain the value for an item, you can the item number by itself. So would you add, inductive reasoning, multiply, pattern, or subtract? So it looks to me like we've got item number 1 and the value's 1, item number 2, the value's 4, item number 3, the value's 9, item number 4, the value's 16. Those numbers are increasing. And it looks like, rather than add, it looks like they are multiplying the number by itself. Now, 1 plus 1 would be 2, and that wouldn't work for 1. 2 plus 2 would work, but 3 plus 3 is not 9. So adding won't work here, and they're not subtracting. So it looks like they're multiplying. Okay, we're going to multiply the number by itself or square it. That's another name for it. So you can use inductive reasoning because this has worked for every other number in the table. We're going to use it for item number 5. Okay, so if we do 5 times 5, or 5 to the second, we're going to get 25. So that would be our prediction for the value of item number 5. And 4 to the second, 16, 3 to the second, 9, 2 to the second, 4, and 1 to the second, of course, is 1. Okay. Moving along. Okay, it says identifying solutions of a 2-variable equation. And you all have encountered these before when you've done lines. I know you've done lines in middle school and as 8th graders and in pre-algebra. It says, is the ordered pair 5, 20 a solution of the equation y equals 4x? Complete the reasoning model below. Now, I'm not going to make you make a table, but they're just trying to get you to think your way through it. It says in 5, 20, I need to identify the x coordinate and the y coordinate. Now keep in mind that they go in alphabetical order. So x is first, so x is the 5, and y is the 20. Now you can substitute 5 for the x and 20 for y, and we see if we get a true statement. So we're going to just sub this in. So where the y is, we're going to put a 20, and where x is, we're going to put 5. And 5 times 4, yep, that's 20. And so we get a true statement. It checks out. So is 520 a solution of y equals 4 times x? Yes, it is. Is it the only solution? No, there are infinitely many solutions for that line. If you plug in 0, you're going to get 0. So 0, 0 is a solution. If you plug in 1, we would get 4. So 1, 4 would be a solution. And you could go on forever naming solutions for that equation. That's just one. And so if they ask you specifically if an ordered pair is a solution of an equation, you simply plug in the numbers for x and y into the equation and work out mathematically and see if you get a true statement. If you do, yep, it's a solution. If you don't, then no, it's not a solution. Okay. For this one, it says using a table, an equation, and a graph. Okay, it says Will runs 6 laps before Megan joins him at the track. So he's already run 6 laps before Megan gets there. They then run together at the same pace. So they're keeping pace with one another. How can you represent the relationship between the number of laps that Will runs and the number of laps Megan runs in different ways? Use a table, an equation, and a graph. Okay, so when Megan gets there, she hasn't run any laps and Will has already run 6. When they run together and she runs 1, he's run 1 additional lap, or 6 plus 1, he's run a total of 7 laps. And then when she runs 2 laps, he will have run 8. And when she runs 3 laps, it's 9. So they keep increasing, but you notice that always Will is 6 ahead of her. So this is going to be 4. When she's run 4 laps, he will have run 10. When she's run 5 laps, he will have run 11. When she runs 6 laps, he will have run 12. And if she runs 7 laps and he stays in there, he will have run 13. Okay? So there's our table. Now, could you make a T-chart? And what I mean by a T-chart is just to make a big T. And this would be Megan. And this would be Will. And we would still have the same numbers as we did, okay? So you can make your table vertical if you wish. Okay. Now, for 8, it says circle the relationship that's represented in the table. Will runs 13 more laps than Megan. Well, that doesn't look like that's the case. Megan runs 6 times as many laps as Will. So we would take Will's times 6. Well, that would mean she's running like 36 and 42 and so on. That's not the case. Will runs 7 more laps than Megan. Well, that's not the case either. Finally, Will runs 6 more laps than Megan. And that is the case. Okay, for exercises 9 through 11, they're going to walk you through finding an equation. If x is the number of laps that Megan runs, and this is where we call what we call defining the variable, and it's important. Anytime we use a variable that's not already there, then we need to tell people what it represents. It's very important. It's important for the end of course exam as well. If x is the number of laps that Megan runs, then y is going to be the number of laps that Will runs. Okay, so we've defined our variables. Now, how do they relate? It says, underline the correct words to complete the sentence. In this relationship, y, which is will always be more than or less than x, which is Megan. Well, he's already run 6 before she gets there, and then he continues to run with her. So he's always going to be, in this particular instance, going to be running more than she. Okay, now we're going to write the equation. So Y will is going to equal Megan's number of laps plus 6. He's always run 6 more than she has. And so there we have our description. On number 8, we have defined our variables in an equation on numbers 9 through 11, and then the table represents the relationship as well. So we've got the table, the equation, and the graph. And if we make a graph, and I think we can do that, here's pretty much how it's going to look. Okay, so of course this is X, that's Megan's laps, this is Y, that's Will's, and then we would just put our ordered pairs in. When Megan has run no laps, he has run 6. And then when she's run 1 lap, he has run 7. And the graph may very well be on the next page, but I want us to kind of see a sketch anyway right here. 2 laps, he will have run 8. And we're going to continue to go up over 1, up 1, over 1, up 1 on this one. Okay. And it will make a straight line. Okay. And here is the graph. I thought we'd run into it, but I wanted to see it with the equation. And so going back to what we were talking about just a second ago, the ordered pair that corresponds to Megan arriving at the track, she will have run no laps. Whoops, that does not work well to write. He will have run 6. And then other tables in the ordered pair, if she runs 2, 6 more than that would be 8, will have run 8. If he's run 10, 6 fewer, that's how many she would have run. This would be 4, and you can grab these numbers from the table. And then you just pick any other number in the table. And let's just do 3 and 4, 2, and 8. And then we just put our ordered pairs on the graph. Now, they only did the first quadrant, and why is that? Well, this is because we're only doing positives. They're not going to run negative numbers of laps, so there won't be negatives on the graph. So that's why they have more of an L rather than the entire, they only have the first quadrant rather than the entire coordinate plane. Now, usually when we make a graph, especially in this situation, we would want to make a title. So, Will and Megan's let's go back and just say, we'll call it a workout. Okay, they put a scale on here for each axis, the x-axis and the y-axis. Every square is 2. Now, Megan, we defined her number of laps to be x. So this is going to be Megan's laps. And we do want to label the axes, and this is going to be Will's laps. And now we're ready to put our ordered pairs on the graph. And again, that would be 0, 6. And then we have the ordered pair 2, 8. So over 1 square and up 4. And the ordered pair 4, 10, which would be right here. And the ordered pair 3, 9, which I'm just going to make it a different color just so we can see that we're going to approximate its location. We go over 1.5 squares. And then we go up 4.5 squares. And you can see that it's part of that line. And of course, if they wanted us to, we would have a line. Okay. Now we're going to look at another pattern. So for this problem, it says extending the pattern. It says use the figure below and make a table showing the number of black tiles and the total number of tiles in each figure. How many tiles in all will be in a figure with 24 black and B tiles, or black B tiles? Okay, so if you look, and yours I know is not in color, but the grayscale is lighter. There is a light gray square in the center and two darker gray squares on either side of it. And then there's 4 black tiles and 2 white. So in figure 1, there are four black tiles, and it looks like there are 9 tiles altogether. And then in figure 2, there are 8 black tiles, and then there are 18 tiles altogether. And in figure 3, there are 12 black tiles, and altogether there are 27 tiles, increasing all 3 colors. Okay, for number 16, it says, for each new figure, how does the total number of tiles change as the number of black tiles increases by 4? Well, the total number of tiles is multiplying by, what's it multiplying by? Is it doubling? Is it tripling? It's increasing by 4, or it's increasing by 9? Well, it's not doubling, because 9 times 18, yeah, that is 9 times 2 is 18, but 18 times 2 is not 27. Tripling would be 9 times 3, which is 18. 18 times 3 is not 27, so that does not work at all. Increasing by 4s, 9 plus 4 is not 18. 18 plus 4 is not 27, so that doesn't work for our y values at all. Increasing by 9. 9 plus 9, yep, that's 18, and 18 plus 9, yep, that's 27. So it looks like it's going to be answer choice D. Okay, a figure with 24 black tiles will have how many total? So we need to work that out. I think we're going to double this number. If we do 24, that's double 12, and if we double this, that's going to be 54 tiles in all. Okay. All right, now we're going to make a table next. So we're going to have to kind of remember these values and remember how those pictures go. So let me move on to the next screen. Okay, so we're going to make a table showing the number of light gray tiles. There's 1 in the center, and the number of white tiles, there are 2. So light gray is in the center, and there are 2 white tiles in every square. So that's something we need to remember. Okay, so if we have one figure, we just have one of those square patterns, then there is 1 light gray and 2 white. If we have 2 figures, there will be 2 light gray, and there's going to be a total of 4 white. And then 3 light gray for figure 3, because there's 1 light gray in the center of every figure, and then there is going to be a total of 6 white. Okay, so there's our table. Now, circle the correct description of the relationship between the figure number and the light gray tiles. Okay, so figure is right here, light gray is right here, and those numbers appear to be the same. Okay, for number 20, it says circle the correct description of the relationship between the number of light gray and the number of white. They are the same, light gray and white, which would be this column and this column is what we're looking at now. They are not the same. The number of white tiles is double the number of light gray tiles. The number of white tiles is triple the number of light gray tiles. Okay, 1 times 3 is not 2, 2 times 3 is not 4, and so on. So it looks like double is what we're getting here. So a figure with 24 light gray tiles is going to have 24 times 2, or 48 white. Okay. And we could get a graph on this. If we graphed it, we would graph the ordered pairs 1, 2, 2, 4, and 3, 6, if we were going to do a graph. over again. There we go. All right. Now we're going to shift gears a little bit and kind of go back to where we started. And they're going to give us an equation. And we are going to see if those are solutions. Okay, so basically it says that the equation is y equals x plus 2. So that means that for every x we add 2 and we get y. So basically we want to know, is 3 plus 2 equal to 5? Is 4 plus 2 equal to 6? Is 5 plus 2 equal to 7? And is 6 plus 2 equal to 8? That's what they're asking us. So, did we check them all? Yeah. Now 3 plus 2, yeah, that's 5. 4 plus 2, yep, that's 6. 5 plus 2, yep, that's 7. And 6 plus 2, yep, that's 8. So all of these are solutions. Okay. Each value of y in exercise 22 is greater than or less than each value of x. Well, it looks to me like it is greater than. So describe the pattern in the solutions of y equals x plus 2. Y is the value of x increased by 2, or 2 more than the value of x. There's multiple ways to say that. Okay. And then we are done. The assignment is posted in Google Classroom. And this finishes up Unit 1. And we will have a test in a couple of days over Unit 1. Have a good day.